Hello, everybody. So let's look at this problem from our assignment, which is essentially about a sphere and how the radius increasing would cause the volume to increase. Okay? And maybe compare with how you would learn this in algebra. I guess if you're learning algebra, what you might do is try to figure out what is the volume of a balloon or a sphere if the radius is known. Okay, but in calculus, where we study rates of change, we study how change in one thing causes change in another, then we might ask if the radius of a balloon, of a spherical balloon, increases, how does the volume increase? Okay, that's what this is about. So I take this formula for the volume of a sphere for granted, and I go from there. All right, so here's my work for it. The volume of a spherical balloon is a function of the radius, meaning that the radius is what you could start with. You could plug that into the formula and you get the volume like this: 4/3 times pi times the radius to the third power. You do that, you get the volume. So part A of this question here, which you can read on your own, says, how does the volume change with respect to the radius when the radius is 6 inches? Okay. And so there I'm thinking, all right, I see change, and I see it says how volume changes with respect to the radius, and that is how we talk about this kind of thing. When we talk about rates of change in calculus, we say, how does this change with respect to that? Okay? How does the radius changing cause change in the volume? That sort of thing. But I would say, like, in this part of our class, we talk about average rates of change, and we talk about instantaneous rates of change. And they're two different things. They might be related. One might have something to do with the other, but they're calculated different ways. So which one are we looking for? It doesn't say, okay? But I can say this. Because of the context here, we're looking for the instantaneous rate of change. And I know that because they gave a, distinct one value of the variable. R is 6. For it to be an average rate of change, it would have to say, how does the volume change with respect to radius when the radius is 6 and then goes to 6.3? Okay, so part A is asking for the instantaneous rate of change, and that's also known as the derivative. Okay, all right, so that is the key we're looking for, is the derivative in part A. What's the derivative when R is 6? Now, how that will answer our question here. I drew a little picture. I'll try to get you to imagine what's going on. It is true that increasing the radius will increase the volume. Imagine inflating a balloon. Both of those things happen. As you inflate a balloon, the radius gets bigger and the volume gets bigger. And here, the derivative, will allow us to investigate how that happens. So, okay, so here's the derivative of 4/3 pi r to the third power, dv over dr. The derivative of volume with respect to radius. To find that, I use the rules for derivatives that I've already learned. So to find the derivative of this, I carry 4/3 and pi into my answer because that is a constant coefficient. 4/3 is a constant, so is pi. Pi is about 3.14, but it's a constant no matter what. So I carry that in, and then the derivative of r to the third power is 3r squared. I can cancel the 3, so I get dv over dr. The derivative of volume with respect to radius is 4 pi r squared. Now, always think about the units. Okay, if we're doing anything that involves calculus, science, engineering, and measurement, then we think about units. Okay, we have to know, like, what are we tracking here? So the units of this number will be volume units over radius units. It's telling me how change in the radius causes change in the volume. How do we measure the volume? Well, if you're measuring the radius in inches, then by extension the volume will be in cubic inches. Okay, so the units here will be cubic inches of volume over inches of radius. Okay, if you want to just say cubic inches per inch, you can do that. All right, so now to answer the question, what is the derivative, the rate of change of volume with respect to radius when r is 6, when the radius is 6? I take my derivative, which you see there, I put 6 in. Here's my notation to tell you that's what I'm doing. It'd be 4 pi 6 squared. That's 144 pi cubic inches of volume per inch of radius. All right. Now, maybe like this is not a fraction, and it'd be good to think of this number in a way that's compatible with the units. So I might think about it as 144 pi over 1, and then it kind of sinks in. I understand something about this. I see what this is telling me. Remember, I started this by saying I want to know, if you inflate a balloon, let's say, how does the radius grow and the volume grow together? How does the radius increasing cause the volume to increase? Like something like that. And now I get this number, I can match up with units. 1 inch of additional radius gets you about 144 pi cubic inches of volume. That's how it happens, at least when the radius is 6. Now, if the radius was bigger, I think you'd get more volume for every inch of additional radius. In fact, you would. But at least when the radius is 6, here's how they're changing together. 1 inch growth in the radius gives me 144 pi cubic inches of additional volume. All right, now my answer to part A is that number, 144 pi. In part B, it says use the rate from part A. Okay, so I'm committed to using my answer in part A. I'm not going to rethink how to do this in part B. I'm going to use the answer in part A. I'm going to use my understanding of the answer in part A. And can I answer by approximately how much does the volume increase when the radius changes from 6 to 6.3? Well, this will tell me, I mean, it says for every inch of radius you get 144 pi additional cubic inches of volume. So I'll write it out like this. This is not the only way to think about it, but I think this is relatable. So if 1 inch increase in radius gives you 144 pi cubic inches of additional volume, then I can just multiply both sides by whatever the change is here. I mean, how much is the radius changing to go from 6 to 6.3? It's changing by 0.3 inches. So if I just multiply both sides of this equation by 0.3, I'll get a statement that answers my question. This is a statement that is an answer to the question. Multiply by 0.3 over here. Okay, it says 0.3 inch increase in radius will give you, or is equivalent to, 144 pi times 0.3 cubic inches of additional volume. There's your answer. All right, that's how much the volume alone is going to grow by this increase in radius. I took my rate of change, my derivative, I thought about the units, I saw that it was 1 to 144 pi. I want to know what it is for 0.3. I multiply by 0.3, and 144 pi times 0.3 is 135.72 cubic inches if you round it to 2 decimal places. Okay, so there's 135.72. All right, now I like this question because, one, we got to understand that, yeah, all these variables are changing together. We get it. The derivative can help us understand how. Okay, to take the derivative, I got to understand, like, some of these things are constants, some are not. 4/3 pi, those are constants. R is a variable. Use the rules of calculus accordingly, get the derivative. Calculate the derivative, understand how the units allow you, and the number allows you to predict how radius change is going to cause volume change, just like I imagined in the beginning. Okay. All right, so that's it for this one. Hope that helps you not only with this, but understand some of the bigger concepts with functions, their derivatives, the units you get, and then how you think about all of it together.